In this video, we're going to go through some practice examples using the perfectly competitive market model. So both the market graph and the representative firm graph used together. All right, we're going to go through six examples. It's the 6 types of shocks you might see on an exam or in an assignment. So we'll start with a positive demand shock, looking at the market for laptops during COVID. Second, we'll look at a negative demand shock, where we'll look at the market for bread when the keto diet becomes popular. Third, we'll look at an increase in variable costs. So in that case, we'll look at the market for cars when the price of computer chips goes up. Fourth, we'll look at a decrease in variable costs. So here we'll look at the market for policing services, and we'll just suppose that the wages paid to police officers fall after the hashtag defund the police movement following 2020. Fifth, we'll look at an increase in fixed costs. And so for that one, we'll look at the market for fish tanks and suppose that factory rent for the factories in which those tanks are made goes up. And then lastly, we'll look at a decrease in fixed costs. For this one, we'll just to say that automation has become cheaper with AI advances. So we'll look at the market for lava lamps and just assume that that product is relies heavily, the production of that product relies heavily on automation. Okay. So let's start with our first one, positive demand shock in the market for laptops during COVID. So as you start off, the way you start any of these problems is going to be exactly the same. So you want to start with drawing your market graph in equilibrium. Where supply and demand intersect is going to define the market price. And that's going to define for the representative firm where their demand curve is. Okay. So I have on my left the market for laptops drawn in equilibrium. And now I am drawing the representative firm graph for the firms in that market. Okay. The demand for that firm is horizontal at the market price. We have upward sloping marginal cost curve showing the amount of laptops that a single firm is producing, right? Its intersection with marginal revenue shows how much the firm is going to produce. And then if we're in long run equilibrium, profits, it should be 0 for each firm. And so our average total cost curve is going to intersect the marginal cost curve where it intersects the marginal revenue curve. So price will equal minimum average total cost, which gets us profit of 0. For each of these examples, there's a few things that we're going to assume. One, obviously, that we're in a perfectly competitive market. 2, that all firms have the same cost curves, so we can show all firms using one representative graph. And then 3, just that the remainder of the assumptions behind perfect competition applies. Okay. Oh, and that each market is in long run equilibrium. All right, that's the other assumption we'll be making. Okay, so now we can go ahead and show the effects of that shock. So we're going to start with our short run analysis. So what happens immediately when we see COVID happen, the pandemic is getting worse, states and nations are shutting down in terms of that people now need to work primarily from home. Okay, so whereas before people were relying on computers at their office, probably desktops, now they need to have laptops for their home. All right, so we see an increasing number of consumers in the market for laptops. And so that'll constitute for us a positive demand shock. Let me make that pen not so thick. Okay, so we're going to shift our demand curve out into the up into the right. That's going to push up the price for those laptops. And increase the quantity traded on the market as well. As the market price goes up, that means that the firm's demand curve also shifts up. Okay, so we see a shifting up of demand following the increase in price. Now, marginal cost intersects marginal revenue at a higher level of output. Okay. So we see each firm producing more, and that's translating to the greater amount of laptops traded on the market. Okay. And then the last thing we need to show here is the profit that the firm is earning. Previously, the firm had zero profit because we're in long run equilibrium, but now price is exceeding average total cost at that new output level. And so our firm here is earning positive profits. Okay, so this rectangle, I'm going to shade it in, is going to show for us the firm's positive profits. And these are profits that they enjoy in the short run. Okay. Now, that concludes our short run analysis. Moving into the long run, remember what distinguishes long run from short run. In the long run, the firm can adjust their capital, right? Whereas in the short run, they can't. So when firms can change their capital use, this positive profit is going to act as a signal to other firms that they should enter the market because there's gains to be had. So we're going to see firms enter the market, and they're going to enter until there's no more returns left. So they're going to enter until we return to this zero profit condition, which we know is at that minimum point of the average total cost curve. So we need price to equal the minimum average total cost again, right? Average total cost hasn't moved, so we need price to go back to where it originally was. And so firms, what we're going to see, are going to enter, shifting that supply curve down and to the right until that price returns, excuse me, to its original level. Okay, so the price goes back down to what it originally was. Quantity traded on the market increases now that we have new firms present. And on our firm side, what we're going to see is that the firm's demand curve is going to follow that price down so that firm's demand returns to where it originally was as well. Okay, so it shifts back down, and as it shifts back down now, it marginal cost intersects marginal revenue at its original output level. So firms are back producing what they were prior to the shock. Now there are just more of them. So we have more firms producing the amount that was produced prior to the shock, and so more quantity traded overall. And lastly, price is back at that minimum average total cost level, and so profits are zero. Okay, so that is our analysis of a positive demand shock using the perfectly competitive market model. Okay, now we'll go to our second example. So this time we're going to look at a negative demand shock. We're looking at the market for bread. When keto is popular. And so if you don't know about the keto diet, it's essentially a no carb diet. I wouldn't recommend it for most people. Long term, it's really hard on your liver. I believe it's your liver. And so it's not good for most people in the long run. Okay, but it's become very popular and has sort of sustained its popularity. So we can use it as an interesting example, right? What happens to our perfectly competitive market for bread when keto becomes a very widespread popular diet that people are following? So we're going to start the same way that we did before. We're assuming that our market for bread is in long run equilibrium, that it's perfectly competitive, and that all firms in the market have identical cost curves. So we can represent all of the firms with a single representative firm graph. And again, assuming that the firm is in long run equilibrium means that it's earning zero profit, right? Each firm is earning zero profit in this market. Okay, so there is our given. Now let's look at the short run. So short run, there's a negative demand shock. Keto becomes popular. People essentially taste change. They don't want to eat bread anymore. So we have people leaving, consumers leaving the market for bread. So we're going to shift our demand curve to reflect that. And we're going to shift it down and to the left. Okay, so that is our negative demand shock. as a result of that change, the price for bread is going to fall, and this is going to push down the firm's demand curve, right? It's going to follow that price, okay? Now, the firm's marginal cost intersects its marginal revenue at a lower level of output, which is going to translate to the market as a lower level being traded overall. Firms are producing less, and now there's less to be traded. Our last thing we need to add on here is the profits that the firm is earning with this change. So now we're no longer at that minimum average total cost point. Now price is below average total cost at that current output level. So what we have in this case is a situation where firms are earning a loss. So we can draw in that triangle to show the loss, right? And that is the size of the loss that the firms are experiencing. Okay. So that ends our short run. Now we can move to long run. Remember, in the long run, firms can change the amount of capital they're using. And so they're going to respond to the prevailing profits and how they adjust. So because profits are negative, they're earning a loss. We're going to see firms exit. And they're going to exit until the last firm that remains in the market is earning zero profit. So they're going to exit until the price goes back to its original level at that minimum average total cost curve, right? Average total cost doesn't change. So it's still defining the same point as that zero profit point, okay? So let's go ahead and graph that. So in response to the negative profits, in response to loss, that signals firms to exit, and they're going to exit until price returns to its original level. So that exit of suppliers, the shift in our supply curve up and to the left, pushes the price back up to its original level. That means for our individual firms, their demand curve returns to where it previously was. And so their output increases to what it previously was. And now they're operating again at that zero profit point where price equals minimum average total cost. And then finally, we have fewer firms in the market producing exactly the same as they were before. And so quantity overall is lower. So that is our total analysis for this second example. We're going to go ahead and move to our third. So our third is going to be an increase in variable costs. And for this one, we said that there would be an increase in the price of computer chips. And we're going to look at the market for cars. So if you remember during the pandemic, this actually happened. Computer chips became more expensive. And it was really difficult for car manufacturers to make more cars because that vital input was so much more costly for them, right? Their input costs went up, okay? So we're gonna see how that impacts our perfectly competitive market for cars. And to do that, again, we're gonna start the same way by drawing our market in long run equilibrium with the assumption that all firms in the market are identical. So we have our representative firm. And that representative firm is going to stand in for all of the other infinite number of firms operating in this market. And again, to show that this is long run equilibrium, we need average total cost, its minimum, to be equal to the price. And that's what we see. Okay, so here is our given situation. And now we need to apply our shock. So our shock, again, is that there's going to be increase in the price of computer chips. And this, we've said, it constitutes an increase in variable costs. So our first step here is we need to identify which of our curves are going to be impacted by variable costs. Okay. First off, neither of our demand curves will be impacted. The neither of them are cost curves, right? They both reflect consumers, right? So any change in producers' cost is not going to affect any demand costs in this market. What it will impact is the cost curves. So let's start on the representative firm side. We know that average total cost is equal to average fixed costs plus average variable costs. So if average variable costs go up, then that average total cost curve is going to be impacted. Okay. Next, we want to consider the firm's marginal costs, right? As we discussed in chapter 7, marginal costs depend on variable costs. So if variable costs change, marginal costs are going to change. And so our marginal costs for the firm is also going to be impacted. And then lastly, our supply curve here, we need to remember, and this is something that students, as I've said before, very often forget. The market supply curve is an aggregate marginal cost curve, right? We find the market supply curve by adding up each of the marginal cost curves for each of the firms in the market, okay? So this supply curve, market supply curve is a marginal cost curve. So anything that impacts the firm's marginal cost is also going to impact the supply curve, okay? So we'll have these three curves changing in response to an increase in variable costs, right? So we'll have variable costs, average total cost shift up, as well as marginal costs. And then we'll also have the supply curve shift up as well. All right, so first off, we're going to draw our new average total cost curve. And then we'll also similarly shift our marginal cost curve. And then what we're going to see happen is the supply curve is going to shift exactly with these other cost curves. It's going to account for the changes in each firm's costs and represent that on the market side. Okay, so what we're going to see is with that decrease in supply, that negative supply shock. So an increase in input costs is going to cause a negative supply shock. To use the same language we've been using before. So that negative supply shock shifts our supply curve up and to the left. That's going to increase the price of these cars. What that means for the firm is now their demand curve responds, and it's going to shift up to be equal to that new market price. And what we're going to see, because demand is tracking the market price, it's going to shift up following the increase in marginal costs and average total costs. I didn't draw this quite right, so let me try to redraw it a little bit. I didn't make the shift clear enough. I didn't give myself enough space here. So average total costs. Marginal costs. And then here is our new demand curve. Okay. Because we're going to see happen, what should happen is that the output produced by each firm is going to fall, right, in response to those higher costs, which is going to translate in the market to a fall in total output traded. Okay, so note now, as we finished our short run analysis, what profit is. Profit now is still zero for the firm. So going into the long run, we want to ask ourselves, do our firms have any incentive to change their behavior? Okay. The answer in this case is no. Why is it no? It's because profit is zero, right? When profit is zero, firms have no incentive to change their behavior. The profit is signaling them to just continue doing what you're doing, right? They're not making gains, they're not making losses. If they tried to adjust, they would make losses. And so it's better for them just to keep doing what they're doing. So in this case, what happens is firms just reduce their output and they stay in that long run equilibrium. Now let's go to example 4. So with example 4, we're going to have a decrease in variable costs. Let me check what the example we planned to use was again. Decrease in wages to police. Okay, so we're going to suppose that the wages for police with the defund or due to the defund movement. Okay, that didn't happen. Really, police officer wages went up, salaries went up, but we're just supposing that that change did occur, okay, for the exercise. So again, we're going to start by drawing our initial long run equilibrium graphs. So we'll have the market for police or police services is what you could think of it as. And we're going to have our firm graph. So this is going to be the representative department or representative officer. Our initial supply and our initial demand on the market side, which is going to give us that market price and an equilibrium quantity. We'll use that market price to trace over to the firm graph and identify the firm's demand curve. Their marginal cost curve is going to intersect with their marginal revenue curve and show us how much how much output, how many hours offering police services will maximize their profits. And then finally, the average total cost curve is going to be tangent to the marginal revenue curve at the point that it intersects marginal cost, showing us that we are in long run equilibrium. Okay. So now we can go into that short run analysis and see what happens when we have a decrease in variable costs, and in this case, a decrease in wages. Right. So again, when variable costs change, we're going to change all of the cost curves that are impacted by variable costs. That'll be average total costs, marginal costs, and the supply curve. Right. So we're going to have average total cost fall. We'll shift down closer to the quantity axis. We're also going to have marginal cost fall, so it shifts down as well. Okay. And supply is going to track with that, right? In this case, supply is going to, what we would say, increase, or there's going to be a positive supply shock because as production costs fall, now there's going to be more producers in that market. Right now, for police departments, it's cheaper to offer or to hire more police officers. Okay? So that supply curve is going to shift down and to the right, and that's going to push down the market price for police services. Okay? With that fall in price, the demand for police services is going to follow it. Okay, so that demand for police services shifts down as well. And now we're going to see that the marginal revenue for the firm intersects its marginal costs at a higher level of output. And the profits, again, like we saw in our previous example, are zero right after the shock. And it's because of this change in supply that's tracking exactly the change in the marginal costs for the firm, each firm. Okay. So with that, we have an increase in output by each individual firm, and that's going to translate to an increase in the equilibrium amount traded. All right. And so that's where our analysis ends. With profit being zero, firms have, or in this case, the police departments have no incentive to change their behavior any further. Right? If they were to change at all, it would result in their profits falling and earning a loss. Now we'll go to our fifth example. This is going to be an increase in fixed cost. And I believe we said for this one, we're going to look at this instance where factory rent increases. And the market we're going to look at is the market for lava lamps, right? So we're assuming that, or is it lava lamps? Let's see what it was. Oh, excuse me, fish tanks, market for fish tanks. And we're assuming that fish tanks are made in a factory. I don't know if that's actually how they're made, but we can assume. All right. So again, we're assuming that this this market is perfectly competitive, that it's in long run equilibrium, and that the cost curves for each firm are exactly the same. So to start, we're going to start by representing that long run equilibrium for each, for the market, excuse me. we'll show our initial supply curve, our initial demand curve, equilibrium price, and quantity. And then that market price defines for the firm their demand curve, where marginal costs intersects their marginal revenue, defines their profit maximizing amount of output, and then the minimum average total cost will be tangent to marginal revenue, where it intersects marginal cost, so that we have that long run equilibrium condition of zero profit. Right. So now we can look at our analyzing our shock. So in this case, we have a fixed cost and then going up, and we're saying that the rent for the factory increases. So just like we did with variable costs, we need to identify which curves are going to be impacted by a change in fixed costs. So again, a change in cost is not going to impact demand, right? Demand is not a cost curve, okay? So we need to look instead at the cost curve. So average total costs, right? That's the sum of average fixed costs plus average variable costs. So we're going to see any change in fixed costs there impact average total costs. Marginal costs, as we discussed in chapter 7, are independent of fixed costs, so marginal costs won't be impacted, and so neither will the supply curve, right? Remember, the supply curve is a the supply curve is an aggregate marginal cost curve. So since fixed costs don't impact marginal costs, it's not going to impact the firm's supply curve. All right, so the only curve then that's going to be changing is the average total cost curve, okay? So when we have our shock, our increase in factory rent, those fixed costs go up, we're going to see average total cost shift up, all right? The amount of output that the firms produce is going to stay the same because there's been no change in marginal cost or demand, right, on their end. And similarly, the market price isn't going to change, and neither will their output, right? No firms have changed their amount produced, so we wouldn't expect any change in that value on the market, right? No change in output on the market, okay? So last thing we need to identify here is how that change in average total cost impacts the firm's profits, right? And now we have average total costs above the price for the good, in this case, fish tanks. And so that means the firms are going to be earning a loss. And so now they have negative profits. So we will expect some adjustment in the long run, okay? But in the short run, all that's going to change is that firms are earning losses, right? They're going to keep operating, keep producing the same amount, but now instead of earning no profit, they're earning negative profit. So again, in the long run, now firms can change their capital so they can enter, exit a market. Because the firms are earning losses, right, earning negative profit, that's going to signal to them that they need to exit that market. So we're going to see firms exit, and they're going to exit until the market returns to zero profit, right? Returns to that zero profit condition. So we know exactly the price that the market will adjust to, and it's that price that equals our new minimum average total cost, okay? So we'll have firms exit. That's going to result in the shift of our supply curve up and to the left. That change in supply is going to cause the price for these fish tanks to rise. As the price of fish tanks rise, we're going to see the firm's demand track that change in price, and it will increase as well, right, to that new price level. Now that the firm's marginal revenue has changed, we're going to see that they're actually going to now be producing more. Each individual firm is producing more, but there are fewer of them. So in the market, that's going to translate to less traded overall. And now that the marginal revenue curve is back equal to the minimum average total cost for the firm, profits have returned to zero. So that's our full analysis for number 5. Now our last example here, number 6, we had an increase in fixed costs, and now we'll do a decrease in fixed costs. And our example here was that automation is cheaper due to AI advances. And we're looking at the market for lava lamps. Oops, sorry about that. Okay. All right. We're assuming again that this change in the price of automation is going to be a fixed cost, right? We're assuming that it's a capital investment that firms have to make before they can start producing, right? If lava lamps are primarily produced via automation, then I need to have those machinery and that code all set up before I start producing any. Okay. So we're going to start this analysis just like we have all the rest by drawing our market for lava lamps in long run equilibrium, with the assumption that it is a perfectly competitive market and that all of the firms have the same cost curves. We'll have our market supply and market demand. Their intersection is going to define the market price, which sets the level of our firm's demand curve. We'll have an upward sloping marginal cost curve, and its intersection with marginal revenue defines how much the firm produces. And then because this market is in long run equilibrium, we're going to have average total cost have its minimum where tangent to the marginal revenue curve where it intersects marginal costs. Okay. And then lastly, we just need to draw in the equilibrium quantity in the market. Okay. So now we can go ahead and show the impact of our shock. We have a decrease in fixed costs. So because we're looking at fixed costs, again, that's only going to impact average total costs. Marginal costs are independent of fixed costs. So the firm's marginal cost curve as well as the market supply curve will not be affected. Okay. And since AI is now, or automation is now cheaper, we're going to see a decrease in the average total cost for the firm. So we can go ahead and show that downward shift of average total cost. Because average total cost is the only thing that changes, the firm's representative firm's output stays the same. And so does that then output on the market. And there's also no change in price. Okay, so the only thing that's changing here is that now the firm's average total costs are below the price for their good. So now they're earning positive profits. So the firms that are currently in the market are very happy about this. They just had automation become cheaper and now their profits are positive. Okay, they're earning positive profits. Moving to the long run, right now firms can enter the market because they can buy capital goods. And so what we're going to see is we're going to see firms enter until the price reaches the new minimum point of the firm's new average total cost curve. Okay, so we'll have firms enter in response to that signal of positive profit. That's going to cause the supply curve to shift down and to the right. As a result, the price for lava lamps is pushed down. This fall in the price of lava lamps pushes down the firm's demand curve. Right? It tracks exactly what the market price is. Now that the marginal revenue curve for the firm has fallen, and it's now equal to its marginal cost at a lower level, output produced by a single firm is going to fall. And that's going to mean that on the market, we still see an increase in the amount traded because now we just have more firms in the market, even though they're all making less than each firm previously did. And then finally, at that point, we're going to have profit equal to zero. Okay, so that's our full adjustment for a response to a decrease in fixed costs. Okay, so you can see that total effect there. All right. If you have any questions on this, this is probably one of the harder aspects of the course overall, to be honest. And so please make sure you study these graphs try some examples for yourself, ask Copilot to give you additional prompts, and reach out, right? If you want to especially bring some more practice into class than what I will have already planned. Okay. Okay. All right. So I'll see you in the next video where we're going to talk about market institutions and their role in the perfectly competitive market model.